Hello students, today we are going to discuss with the substitution nucleophilic unimolecular reactions. It is a part of a haloalkanes and haloarenes. Now, basically when we talk about the nucleophilic substitution in alkyl halides, it have the two mechanisms. The first mechanism is one with the substitution of nucleophilic unimolecular, and in the short form we called it as a SN1. Now, SN1 reaction, the key features of the SN1 reaction is what? It takes place in the two steps, and the reaction is of the first order. Now, what happens when we are talking about the step 1? In the step 1, the alkyl halide undergoes slow heterolysis to produce carbonium ion. Over here, the heterolysis means the bond is being broken down and the arrangement of the carbon ion is going to take place. Now, this carbonium ion means what? That heterolysis means what? That the plus and minus charges came. So, we have got the carbonium ion. This carbonium ion is going to act as a intermediate over here. And we are going to get the halide ion. Now, if I look it as a reaction, say suppose I am having the three different alkyl groups and they are attached to the carbon atom. Basically, I am having the alkyl halide. So this particular step is going to be a slow step and it is going to give rise to the carbonium ion. Now, when it is going to give the carbonium ion means that there will be the plus sign. Plus, we are going to have the halide over here. Now, when we are coming to the next step, we have got the carbonium ion over here. So, the next step is going to come, that is your step 2. Now, in the step 2, what happens that the nucleophile rapidly combines with carbonium ion. To complete the substitution reaction. Now, what is going to happen in this particular step? In this particular step, we are having the carbonium ion. This carbonium ion is being attacked by the nucleophile. When it is being attacked by the nucleophile, what is going to happen? It is going to come and attach over here. Now, in the SN1 reaction, the key features or the main points are what? That whenever the SN1 reaction is going to take place, what we say that it is a optically active halides. Now, say suppose we are having a certain halide which is optically active, then it is going to be accompanied by a racemization. Now, why this happens? Because during this process, the carbonium ion formed in slow step being sp2 hybridized means planar, or you can say achiral. Therefore, what happens? The attack of nucleophile on it can take place from both the faces. Now, from both the faces means what? Let me show you with the help of the diagram. Now, say suppose we are having the bromine. This is the CH3. Then I have a dash bond and the solid bond. Now, as I told you, achiral carbon atom is the one which is having the all different function groups. Now, what is going to happen in the step one? In the step one, it is going to give us the carbonium ion. So over here, a plus charge will come and a halide is going to separate out. Now, moving ahead, what is going to happen on this particular? Let me make it again. CH3 CH2, CH3H. Now over here, we are going to have the two possibilities. So let's look what are the two possibilities in this particular case. Now, what will be the two possibilities? That as we have got the carbonium ion, now we are having the nucleophile. Now, one is the frontal attack. Frontal attack means that where we was having the halide, this portion, there only you are going to have the attack of the nucleophile. Now, that particular condition is going to called as a retention. And if in the case you are not going to have the frontal attack, but you are going to have the rear attack. Rear attack means from the back side, means from the opposite side of the halide where it was present. It is going to called as a inversion. So, what will be it then? CH3 OH over here H and CH2 CH3. This is we are going to get in the case of the retention. But if it is going to be the inversion, then we are going to have the CH2 CH3 and H, this particular. So this is how we get the SN1 mechanism. Once again, I am repeating it. In the case of the SN1 mechanism, you have to remember that it is called as a substitution nucleophilic unimolecular reaction. Basically, ये reaction दो steps में होगा. दो स्टेप्स में होने के बाद हमें ये ध्यान में रखना है कि ये रिएक्शन जो है ये फर्स्ट ऑर्डर रिएक्शन है. अब इसको हम फर्स्ट ऑर्डर रिएक्शन क्यों बोलते हैं? बिकॉज इट्स रेट ऑफ रिएक्शन डिपेंड्स ऑन concentration of one substance, that is your alkyl halide. अब स्टेप वन में आप जो भी अल्काइल हैलाइड लेंगे उसका स्लो हीटेरोलिसिस होगा. हीटेरोलिसिस का मतलब होता है कि जो ये आपका हैलाइड है ये इलेक्ट्रोनेगेटिव इन द नेचर है, तो ये इलेक्ट्रॉन्स क्या करेगा, ये अपनी तरफ पुल करेगा, जिसकी वजह से कार्बन के ऊपर प्लस चार्ज आ जाएगा. तो आप इसको क्या बोलते हैं कि ये कार्बोनियम आयन है. अब ये जो कार्बोनियम आयन है ये ऐड करता है एज अ इंटरमीडिएट. तो सेकेंड स्टेप में क्या हो जाएगा कि न्यूक्लियोफाइल जो है वो अटैक करेगा. न्यूक्लियोफाइल क्या होता है? न्यूक्लियोफाइल होते हैं इलेक्ट्रॉन रिच स्पीशीज. अब जब इलेक्ट्रॉन रिच स्पीशीज है तो ये वहां अटैक करेंगे जहां पे इलेक्ट्रॉन्स की कमी है. तो न्यूक्लियोफाइल जो है अल्टीमेटली कार्बोनियम आयन पे अटैक करेगा और आपका जो सब्स्टिट्यूशन रिएक्शन था वो कंप्लीट हो जाएगा. अब यहाँ पे जो इम्पोर्टेंट चीज है वो ये है कि जो SN1 मैकेनिज्म अगर होगा और आपके पास कोई ऑप्टिकली एक्टिव हैलाइड है तो रेसिमाइजेशन होगा। रेसिमाइजेशन क्यों होगा? क्योंकि कार्बोनियम आयन जो बना है आपका स्लो स्टेप में वो sp2 हाइब्रिडाइज्ड है। sp2 हाइब्रिडाइज्ड यहाँ पे इसकी वजह से क्या हो गया? वो अकायरल है। अकायरल कार्बन आटम का मतलब वो कार्बन आटम जिसकी जो चारों ग्रुप्स अटैच्ड हैं वो डिफरेंट ग्रुप्स हैं, एक भी सेम नहीं है। तो सेम स्टेप होगा स्लो स्टेप के अंदर कि आपके पास कार्बोनियम आयन आ गया। अब कार्बोनियम आयन के ऊपर जो भी अटैक होता है न्यूक्लियोफाइल का, या तो वो फ्रंटल इफेक्ट होगा, फ्रंटल मतलब आगे से मतलब जहां पे आपका हैलाइड अटैच था, या फिर पीछे से मींस अपोजिट टू द अटैचमेंट ऑफ हैलाइड। तो अगर आगे से होता है तो उसको आप बोलेंगे रिटेंशन, पीछे से होता है तो इन्वर्जन, एंड इस मैनर में फिर हमको उसके प्रोडक्ट्स मिलेंगे। सो आई होप यू अंडरस्टूड द मैकेनिज्म ऑफ SN प्लांट। हैव अ गुड डे।